So many thanks for giving me this opportunity to share some of the econometric models while estimating or I'd say while answering some of the empirical questions that we face in financial economics, right? So to start with, uh, I can see that there are many participants who are actually pursuing their PhD, and there are participants who have already completed their PhD and working as a faculty member. And I assume all of you have some way or the other related to this financial economics, right? Now, the application of econometrics in finance is very vast, is huge actually. So it is very difficult to cover the entire application of econometrics in finance in one or two sessions. So that is why I have taken only one particular topic, which is quantitative response model, and then I would like to show the application of that particular model in finance. So I would be taking help from Biju and the other technician uh, while sharing my screen. I have some PPT. So Biju, can you please help me here in? I am not so familiar in WebEx. So if I go to share, so
Share. Go to share.
and then
Yeah, it's visible. Put it on slideshow mode. Then it will be okay.
just 1 second. This is view. I should go to enter full screen, right?
Yeah.
Yeah. So this is the qualitative response model. And before I start this model from the audience, I would like to get some quick responses. How many of you have not yet exposed to econometrics?
Audience can use the chat option.
How many of you have no exposure to econometrics at all? If I don't receive any response,
Snehit host, please check the chat option is working or not.
Yes, sir. I will enable it now.
Only those should respond who have not exposed to econometrics. Others who are having some kind of exposure to econometrics
Results are coming. The results are coming up, sir.
Okay. Okay, so that means that's enough. That's fair enough. So that means what I can see that there are some participants who has not yet got any exposure to econometrics. Now the topic what I have taken it is little advanced level econometric models. So what I will do, I will first tell you what is econometrics before I start with this qualitative response model. In nutshell, basically econometrics is the application of mathematical and statistical tools to empirically validate economic theories. That's all. So in economics and finance, you might have studied many theories. For example, from economics, I can take the very simple economic theory, which comes from the demand, right? Where we came across a theory called law of demand, which says that as price increases, quantity demand fall. Now the question is, if you want to quantify for a particular percentage change in price, what should be the exact percentage change in quantity demand? then what we need to do, we need to basically apply econometric tools that will help us estimating a demand function. And depending on the magnitude of that a particular coefficient of price, we will come to know that what is the exact impact of a price change on quantity demand. Now, even though this particular subject was first introduced by economists, in today's world, what we see the application of econometrics is much wider than what initially it was. So in today's world, we apply econometric tools in economics, in finance, in marketing, then even in other social science discipline as well as science and engineering disciplines as well. And when we talk about finance, I would say that it is actually not possible to do any empirical finance or empirical research in finance without understanding the econometrics. It's so important. So there are certain steps involved in econometrics. So I would just like to take you step 1, 2, 3 like that. Step 1, step 2. So what is the first step? In any econometric analysis, the first step would be to hypothesize some kind of relationship. For example, in the context of demand, I was hypothesizing a relationship between price and quantity demand. And what is my hypothesis? My hypothesis is that as price increases, then quantity demand falls. So this is some kind of inverse relationship between price and quantity, right? Similarly, in the context of business and finance, you might be interested in what are the factors that might influence the profitability of a firm. And let's say you are hypothesizing that as sales, R&D, and export intensity increases, the profitability of the firm also increases. So that means you are basically hypothesizing some kind of positive relationship between this independent variable with the dependent one, which is profitability in this context. Now, once you hypothesize a relationship, then our next step would be to basically convert that hypothesis into a mathematical model. For example, if you consider X is price and Y is, let's say, demand, then we have to express the relationship using a mathematical function Y equals to alpha plus beta X kind of model, right? In this context, I'd like to give you an example. Let's say this is one model wherein I have mentioned yi equals to alpha plus beta xi plus ui. Now, this particular model here, we are calling it binary response or qualitative response model. Why this is called binary or qualitative response? Because unlike the price and quantity demand, where quantity demand is a continuous variable, it can take any value from 0 to infinity. It can take any value depending on a price. The quantity demand can be 1, 2, 3, 4, 10, 100, 150 like that. But sometimes our dependent variable are binary in nature. For example, we might be interested in this type of questions. Why do some individuals own their own car while others prefer public transport? Like similarly, we may also encounter this type of problem. Why do certain individuals possess their own apartment while others prefer to stay in a rented apartment? Why do some individuals loan gets accepted very easily or approved by the bank easily while others they face a lot of difficulty in their bank loan approval? In the context of finance, I would like to give you certain specific example. Let's say we are trying to understand why do some firms go for external financing while others they depend only on their internal resources. So that means in this case we will denote the dependent variable yi, and the yi will take only two values. Yi would be equals to 1 if the firm goes for external financing. And when I'm talking about external financing, I hope all of you know what is external financing. If you don't mind, can anyone from the audience help me telling what exactly you mean by external financing. Just anyone. If you have any idea about the financing pattern of a firm, internal versus external financing, please tell me your idea of external financing.
Please unmute your mic and say.
No, you can answer instead of writing in the chat box. You can one or two.
Debt loan from external parties.
It's lending from outside, either from the financial agency or any other form of investment from the external source. And in return of that, you need to pay the interest or return sharing.
Thank you. Thank you very much. Exactly. That is what called external financing. You might be issuing some equity, you might be issuing some bonds, you might be issuing certain other instruments to raise money from the market, for which you have to either share your profit or you have to pay interest if you are issuing bond. So this is called external financing. Now, the question here is that means there are two choices here in front of the firm. The firm can either go for external financing or they can use their internal resources. And I am a person here to understand what are the firm specific factors that actually determine which particular mode of financing the firm will go for. And this X, this capital X, is basically a vector of all those firm specific factors. It might be the riskiness of the firm, it might be age of the firm, it might be total assets of the firm, it might be ownership of the firm, it might be the industrial structure of the firm, so on and so forth. So that means this X basically captures many different variables that will actually explain which particular mode of financing a firm will go for. Similarly, we can also try to understand why do certain stocks they give dividend while others they do not. We may also try to understand why do certain firms they go for listing their stocks in Bombay Stock Exchange while others keep away from it. So these are, in all these cases, if you look at the dependent variable y is basically binary in nature. So that means either you pay dividend or not. If you pay dividend, then this yi will take the value 1, 0 otherwise. If your company is listed in Bombay Stock Exchange, then this will take 1, otherwise 0. If your company is paying dividend, then yi will take 1, otherwise 0. So that is why this model is called binary response model. This yi is the response variable, and since it is taking only two values, 0 and 1, this is called binary response model, right? Now there are basically three types of models to handle with this type of situation, and I will take you through all these three types of models in today's lecture, and tomorrow or in our next class we will try to understand how to estimate those models using a data and applying the econometric software which is called Stata. And today's lecture is specifically on the theoretical part of these three type of model, right? Now, the first model, as you can see from here, this is called linear probability model. Now, why this is called linear probability model? Because here we assume, let me take you through the model. Look at here. I have mentioned a model yi equals to alpha plus beta xi plus ui. This is the model, and we assume yi equals to 1 if an individual is having a card, 0 otherwise. You can take any example, the same model will work. Instead of taking this example, you might be thinking that yi takes the value 1 if a particular company is listed in BSE, 0 otherwise. And what we assume that probability pi, this is probability yi takes the value 1, that is denoted by pi, and this is probability yi equals to 0, which is denoted by 1 minus pi. So you can think of probability. PI is basically the probability of a success. Success means the event is actually happening. The individual is having a car. We call that event as a success in the literature of probability. Nothing else. It's very simple. If the company is listed in Bombay Stock Exchange, then we will call that event as success. If it is not, we will say it's failure. Failure does not mean the company is failure. Company's failure. Rather, I will say that failure means it is these two terminologies are actually we are borrowing from the probability literature. So if you take the expected value of it, you will get then how do you calculate expectation? You have to multiply the values with the corresponding probability. So you multiply pi with 1 and 1 minus pi equals to 0 into 0. That will take you to pi. So that means expected value of yi is basically the probability that the event will happen or not. Since the expected value of the dependent variable indicates PI, that means which shows whether the event will happen or not, we say this model is linear probability model. Why this is called linear probability model? First of all, the probability part is clear because this model simply indicates what is the probability that the event will happen. And since the probability is actually a linear function of this x, we call it, we look at this equation 6 where we have said that pi is basically alpha plus beta xi. So that means probability that the event will happen is a linear function of x. That is called linear probability model. That is the first model econometrician they introduced to understand this type of situation. Now, this linear probability model, it has some limitation. What is the limitation? Limitation is that if you know that probability has some specific characteristics, probability of happening an event must always lie between 0 and 1. Probability cannot go beyond 1 and 0. Okay, it should always lie between 0 and 1. But the moment I introduce this probability as a linear function of x, then there is a danger involved in it. What is the danger? The danger is, suppose this is the probability of owning an individual for owning a house, right? Owning a house. And this x is basically income. So it says as income increases, probability of owning a house is also increasing. Now, you will agree with me that when an individual's income increases from 10,000 to 20,000, obviously there will be a great jump in the probability of owning a house. Then again 20 to 30,000, 30 to 40, 40 to 50. If the income increases up to certain range, the probability will increase. But now, if you keep on increasing the income, it may so happen that at one point of time, your estimated probability is exceeding 1 because you are increasing your xi just like that. So that means the model at that stage will not make any sense. Probability cannot go beyond 1, right? So it should always lie between 0 and 1. So that means this linear probability model, the way we model it, it has some severe limitation. Even though econometrician, they introduce this model as their attempt, it has several limitations because of which later on econometrician, they introduce non-linear models. Okay. So up to this, I stop here. Up to this, if you have any doubts, you can quickly raise one or two doubts from the audience so that I can clarify or answer your doubt. This is the starting point of this qualitative response model. Quickly. Please ask if you have any doubt.
Nobody have doubts. Hope so.
Okay, so up to this stage, nobody has any doubt, right? So it has two implication actually. Either implication number one, whatever I am saying, it's very crystal clear to you. Number two, whatever I am saying, it is not making any sense to you, so that you are able to raise any doubts. I hope the implication is the first one, that everything is clear, not the second one, right?
Yes, sir.
Okay, fine, fine. So once we are done with this linear probability model, that means we understood it has several limitations. I am not discussing all the limitations because the time is short. So the main limitation is this linear probability model cannot restrict the estimated probability within the range of 0 to 1. That is the main limitation of this linear probability model. Now, these are the limitations, but I am not going to discuss each of these limitations, because that will take some time. So I will take you directly to the logic model. To overcome, to overcome this limitation, instead of hypothesizing a linear relationship between Pi and the set of independent variable xi, what the econometrician they did, they hypothesized a relationship in this way. Pi equals to 1 by 1 plus e to the power minus zi, where zi equals to alpha plus beta xi. Right? So this type of specification, this 1 by 1 plus e to the power minus zi, this is basically called logistic function, or more appropriately the cumulative logistic distribution, and that is why the name logic model, nothing else. So earlier we said pi equals to alpha plus beta xi. Here I am saying pi equals to 1 by 1 plus e to the power minus zi. Okay, that is the uh, that is the specification that I'm mentioning. Now, if you have pen and paper with you, you can do some mathematical manipulation. So what I am asking you to do is basically divide this equation both the sides by 1 by 1 minus pi, then what you will get pi by 1 minus pi. And if you do so, you will see that pi by 1 minus pi equals to e to the power minus zi. If you have pen and paper, you can quickly check actually. Pi by 1 minus pi is e to the power minus zi. And if you take logarithm of both the sides, then log of pi by 1 minus pi equals to alpha plus beta xi. Now this model can be estimated since it becomes a linear, equivalent to linear model. This was little problematic because this is a nonlinear kind of specification. By doing some simple mathematical manipulation, what we did, we basically linearized it. So log of pi by 1 minus pi equals to alpha plus beta xi. Now this pi by 1 minus pi, it has some interesting implication in econometric literature. This pi by 1 minus pi is basically is known as odds ratio. Okay, odds ratio. So that means odds in favor of happening an event. Since pi is there in the numerator and pi indicates probability of happening the event, so pi by 1 minus pi is called odds ratio. And the moment I take log, it's called log odds ratio. So you have to always keep in mind while estimating a logic model that what is the specification that you are estimating. It is log pi by 1 minus pi equals to alpha plus beta xi. Okay, alpha plus beta xi. Now, the point here is, if you want to estimate this equation, using the data that you have collected, so I will just ask you to visualize your data structure. What you have to do, let's say you want to understand why do certain individuals they have uh, their own house while others they prefer to stay in rented apartment. So let us say that you are conducting a survey. You go to each and every house, every individual, and ask them, is this house your own or rented one? If the individual says, yes, it is my own, then you will put 1 for y. Let us say that you have created one Excel sheet where y is for the dependent and you have x1, x2, x3, x4. These are all independent variables. So in Excel sheet, you will get in y column 1, 1, 1, 0, 0, 0, 1, 1, 1, 0, 0, 0, 1, 1, 1, 1, 0, 0, 0, like that. So this is y column. So, and in X, you have individuals' income, you have individuals' age, so on and so forth. Now, while estimating this model, you need PI and 1 minus PI. Can anyone tell me if you have that type of information, what I will specify here in this model? I have information on yi, which is 0, 0, 0, 1, 1, 1, 0, 0, 0, 1, 1, 1, depending on whether the individual is having his or her own house or not. Using that information, how will you estimate this model? That means here in place of PI, what should I put? PI is basically probability of owning a house.
So I should write, sir, 1 divided by 1 minus not happening that event.
Yes, exactly, exactly. So now the question is, let's say you are putting PI equals to 1. Okay, if you put PI equals to 1, what will happen? The left hand side will become log of 1 by 1 minus 1, 0, and 1 by 0 is infinity. So that means your dependent variable becomes log of infinity. Does it make any sense? Your dependent variable is log of infinity. Does it make any sense?
No sense.
It does not make any sense. Now, someone else will tell me, no, sir, instead of 1, let me put 0. What will happen? If you put 0, then this will become 0. That will become log of 0. That also does not make any sense. So that means neither 1 nor 0 I can substitute for PI. Then the question is why? I am saying PI is probability, but then I am not able to put 1 and 0. What is the problem? What is the problem? Why is it happening? Because in the model itself, I have specifically mentioned that PI is the probability of happening an event. But the moment I put 1 and 0, then this model becomes difficult to estimate because the dependent variable becoming log of 0 or log of infinity. What is the problem? Do you see any problem here? Yes, there is a problem, but the problem is little difficult to understand. See, here I am saying PI is basically the probability of happening an event. What is YI? YI is basically called in econometric literature, it's called realization. That means we can only see whether the event has realized or not. We cannot actually visualize the probability. Probability is something you cannot observe. Do you think I can observe probability? No. I can only observe the end result, whether the event has happened or not. How can you ensure that the end result is equivalent to probability? That is not. Probability is something which you cannot observe. We can observe only whether the event has happened or not. That means we can only observe the realization. So one thing we must keep in our mind that this PI is actually not equivalent to YI. YI is the realization which we can observe. PI is the probability which we are trying to estimate. It should lie between 0 and 1. Okay, so the moment we assume PI is equivalent to YI, the problem starts there because we have not differentiated realization with probability. Probability is quite different from realization. We can always observe only realization, not the probability. That's why never ever use 1 or 0 here to estimate the model. That means, given our data set, we cannot create the dependent variable for our estimation. That means we cannot use the ordinary least square technique or OLS. Those who have little idea of econometrics, you might have studied about ordinary least square technique, wherein you try to minimize the sum of the error square. So here that technique is not applicable because I am not able to create my dependent variable. Then the question is, if that is problematic, what is the solution? Now to overcome this solution, overcome this problem, econometrician, they suggested a different route. What they say that we need to introduce a statistical concept called likelihood function. What is likelihood function? Likelihood function is basically related to probability distribution function. Uh, any one of you from the audience, are you familiar with probability distribution function or probability distribution? Let's say binomial probability distribution, Bernoulli probability distribution.
Yes, sir. There are three distribution: Poisson, normal, and binomial.
Binomial. Now, in probability distribution, what is known? The known is actually the parameters. So that means if I know the probability distribution and if I ask you, if I toss a coin n times, you can easily calculate the probability of getting some 10 heads or 15 heads or 20 heads. Like that's very simple, right? Don't you think if I give you the probability distribution and if a coin is unbiased and I ask you if I toss the coin 15 times, what is the probability of getting 10 heads? Don't you think that it is possible to calculate?
Sir, it is possible.
Yes, sir, it is very simple. That is the use of probability distribution function. Now I am asking you to think it differently. Let's say I am saying you, I know how many times I am tossing the coin. I also know how many heads I have observed. Let's say occurring head is called success and occurring tail is called failure. So I already know how many heads have happened. That means I already know the number of success in these 15 trials. Now I am asking you, can you tell me what is the distribution? That means what should be the parameter of the distribution that will give me this many number of success when n equals to, that means number of trial equals to 15.
Then we can use Poisson distribution.
No distribution will work in this case. I'm talking about, it's a different type of concept I'm asking you to think about. It's a different concept related to probability distribution. In all this probability distribution, the parameters are known. If you take Poisson, binomial or not, every distribution is defined in terms of parameter, like pi, the success, and n. So in probability distribution, parameters are known. We can always calculate the number of success, probability of this many success. Suppose the parameters are known. I know how many times I tossed the coin and how many heads I got, but I don't know what is the distribution that has led to this type of situation. That means indirectly, let me say that I'm asking you to think of a situation where I have interviewed some 100 individuals. That means n equals to 100. Out of those 100 individuals, let's say there are 40 individuals who have their own house. So that means 40 is the number of success. But I don't know what is the value of this alpha and beta. That means the parameter that will lead to this type of sampling. So that means I'm asking you, from a given population, you can actually draw n number of samples. From a given population, you can draw n number of samples. I have observed a particular sample. And in that particular sample, out of 100, there are 40 individuals, they have their own house. If you draw another sample, maybe the number of owning a house will vary from 40 to 50 or 40 to 30, something like that. Now I am asking you, can you tell me what should be the value of alpha and beta, that means the parameters, that will maximize the probability of observing a particular sample from the given population? And that is basically the idea of a likelihood function, and that is basically the idea of maximum likelihood estimation that is required to estimate a logic model. Now the idea of likelihood function and maximum likelihood function, it's not very easy to understand, but it is not very difficult also. What I am saying, you just have to think a related but opposite of probability distribution. What is known in case of probability distribution, that is unknown in the context of likelihood function. Okay, parameters are known in probability distribution, which are unknown in case of likelihood function. Number of success probability you have to estimate. You can estimate the number of probability of happening this many number of success. In likelihood function, I already know how many successes happen. Okay, I already know. Okay, so that means which is known here, that is unknown there, which is known there, unknown here. So that means basically in likelihood function, in short, I am asking, I have collected a particular sample in which out of 100 individuals, there are 40 individuals who have their own house. And I am asking you, tell me, what should be my value of alpha and beta that will maximize the probability of observing that particular sample. Okay, now how do you do it? Basically, this is how we do it. Let's say L is the probability of observing the entire sample. Now, probability of observing the entire sample is nothing but probability of observing y1, y2, y3, dot, 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 yn. So that means we can say that by multiplicative rule, we can say that this is basically probability of y1 multiplied by y2 multiplied by y3 dot, 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 yn. Okay. So now what I will do, then I'm calling it. Let's say I have n number of individuals and I have arranged my sample in such a way that first n1 number of individuals will have their own house, while the remaining n2 number of observations or individuals, they don't have their own house, while n1 plus n2 equals to n. So what we can say that probability y1, y2, yn, this is basically, this should be n, this is not n1, this is n. So this should be p1, p2, dot, 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 pn1. Okay, after that, so that means what I said for the first n1 observations, everybody is having a vehicle or house, that is why it is p1, p2, that means it is expressed as p. Starting from n1 plus 1th observation, we will have 1 minus p into n1 plus 1, 1 minus p into n1 plus 2, dot, 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 1 minus pn, which is very simple. Basically, I am saying pi indicates probability of success and 1 minus pi indicates probability of failure. Now, this particular statement, how will you write in compact form? This I can write I running from 1 to n1 pi multiplied by, this is actually a product sign, and here also another product sign, wherein I am saying I running from n1 plus 1 to n, and this is 1 minus pi. So I'm sorry that there is little difficulty in notation. Here it is I running from n1 plus 1 to n. Here it is I running from 1 to n1. And here it is pi, here it is 1 minus pi, that's all. This I can write as, again the product I running from 1 to n1, pi to the power yi into 1 minus this entire thing, what I can write, I running from 1 to n actually, not n1, pi to the power yi into 1 minus pi to the power 1 minus yi. Why I am writing in this way? Because for the first n1 observation, yi equals to 1. So if you put yi equals to 1, then this will become pi. For the remaining observation, yi takes the value 0. So 1 minus pi to the power 1 minus yi. If you put 0 here, that becomes 1 minus pi. Now, why I am writing this in this way? Because if I write this in this way, and if I take logarithm of both the sides, then what I will get, log L equals to I running from 1 to n1 log of pi plus summation I running from 1 to n1 plus, this is actually I running from n1 plus 1 to n 1 minus yi into log of 1 minus pi. Right? And here I can substitute pi for 1 by 1 plus e to the power minus alpha plus beta xi. That is the pi. Now what I have to do, that means in logit model, here then I have to maximize this like log likelihood function with respect to the two parameters alpha and beta. And when you maximize this function, that particular alpha and beta for which this function is maximized, I will take that alpha and beta as the estimated value. So this is quite different from the ordinary least square technique that we have learned earlier. Okay, so that means the likelihood function is basically the probability. So this is what I have mentioned, and in this specification, when I'm writing pi equals to 1 by 1 plus e to the power minus alpha plus beta xi, or in short, if I write 1 by 1 plus e to the power minus zi, that means if zi runs from minus infinity to plus infinity, pi will always run from 0 to 1. That is the advantage of this logic model. So when zi ranges from minus infinity to plus infinity, pi will range between 0 and 1. Okay, this is basically the logit model. So that means whenever you come across a logit model to estimate a binary response type situation, please remember that means we are estimating this one. That means we are trying to maximize log of L with respect to alpha and beta. Now you can easily understand how difficult this maximization problem is. Okay, how difficult this maximization problem is. But thanks to the statistical software's data, we actually don't have to maximize this manually. Rather, using some simple command, data will easily estimate these models for us. Then the question is, if it is so easy, why we are understanding the theory behind it? We are trying to understand the theory behind this, because if we don't understand the theory, then we will not appreciate what data is actually doing behind the curtain. We will also not be able to understand what is the real flavor of econometrics. In most of the cases, we generally don't bother to read and understand the theory. We simply look at the command which is readily available in Google, and then we'll try to estimate the model. And that is how we do econometrics, and we come up with some kind of nonsensical interpretation of the coefficient, because we don't know what we actually estimating. So whenever you estimate a model, first of all, you need to understand this is our specification. Pi equals to 1 by 1 plus e to the power minus zi, or pi equals to 1 by 1 plus e to the power minus alpha plus beta xi. Okay, and this is the technique, maximum likelihood method, wherein this is the model log L equals to this condition. That is what we are trying to maximize. Since we are applying maximum likelihood method to estimate a logit model, please keep in mind that this maximum likelihood method requires minimum 200 to 300 number of observations to give you reliable estimates of your parameter alpha and beta. That's why it is not possible to estimate logit model if your number of observation is less than 100. More is the better. So whenever you are trying to apply this type of model, please ensure that you have minimum 200 to 300 observations in your hand. Your sample size should be of minimum 2 to 300, not less than that. Okay, because this requires maximum likelihood estimates. All right, so up to this logit model, again I will give you a pause of a minute, and I will ask you if you have any doubt up to this. If you have any doubt, please ask me.
So we can continue, sir. No doubts.
Okay. So if you don't have any doubts, then what we will do in our next model, what we'll try to understand as a probit model. As I said initially, that we have three types of model: linear probability model, the logic model, and next one is the probit model. Right? Now the probit model, to understand the probit model, we will take an alternative route or indirect route through which we can actually derive both linear probability model, LPM, logic, and probit, everything. Okay. Now here in probit model, we consider a latent variable y star. Y star is called a latent variable. What is latent variable? Latent variable is basically something which we generally impossible to observe, but that actually plays an important role in our decision making. For example, while deciding about whether to buy a car or not, what do we think? Now I want an answer for this question. Suppose you have some amount of income and you are thinking whether to buy a car or not. All right. So what kind of thinking goes in your mind? From the audience, please. How do you decide whether to buy a car or not? What goes on in your mind while deciding whether to buy a car or not? This is a very simple question. Why the audience is so silent?
It's available, the fund and budget. That's the first question.
No, no, you have money. You have some amount of money, and then what you will do?
You will do the
Suppose
research.
your budget is allowing you to buy the vehicle. Do you think that you will buy it?
You will see that is it required for you, and you'll do some sort of a research on your side.
Exactly. That means what we do, we think that if I buy the car at this level of income, what is the satisfaction or utility? In the language of economics, we call it utility. So, how much utility we can derive, right? So, if we get a positive amount of utility, that means if there is a positive, if there is a threshold level of utility that we are deriving from the model, then only we can say that this yi, which actually we can observe, will take the value 1. Zero otherwise. So we need to derive some amount of utility or use out of it, then only we'll go for buying a vehicle or owning a house. It's not that just because we have money, we'll go for it. We always calculate the utility. Now, utility is something which you cannot observe, which is unobserved, but that plays an important role in this decision making. Okay? So utility is unobserved, only the decision whether to buy or not. That means whether you have bought it or not. That means again, we will observe only the realization. Okay. So yi is the decision or the event has happened or not, but yi star is only the latent one, which is related to yi in this way. How? Yi equals to 1 when the individual derives a positive amount of satisfaction, 0 otherwise. So that means we can say that probability yi equals to 1 equals to probability yi star greater than 0. Right? Similarly, what I can say that from this statement, then I can indirectly say that probability yi star greater than 0 when probability, how will you get this yi star? It's very simple. If you go back, if you have to get the probability yi star greater than 0, that means this negative of this should be greater than, or ei should be greater than negative of alpha plus beta xi. Very simple mathematics. If the epsilon I is greater than negative of this, then only this would become positive. The same condition I am applying here. Epsilon I is actually greater than negative of this. And from this is actually following from the definition of cumulative distribution function, nothing else. When probability epsilon I is a random variable, is greater than a specific value, we can write this as 1 minus actually this, there should be a negative sign here, f of minus of this, 1 minus f of minus of this, where f is basically the cumulative distribution function. Since there is a negative sign over here, this negative actually 1 minus f of negative over here, that is actually equals to f of this. So that means ultimately we have arrived at that probability is actually is equals to the f of alpha plus beta xi. Now, depending on which particular functional form this f of alpha plus beta xi will take, we will get three types of model, either LPM or logit or probit. How? Look at this. When f of alpha plus beta xi equals to alpha plus beta xi, then it is a linear probability model. When f of alpha plus beta xi equals to 1 by 1 plus e to the power minus alpha plus beta xi, we call this is a logit model. And then when f of alpha plus beta xi, it's a normal CDF, then we call a probit model. That means logit and probit, they are actually same. But the thing is, we need to understand when to apply logit and when to apply probit depending on the situation. As you see that logit model applies logistic CDF and probit model applies normal CDF. Now logit model, if you look at logit model and this cumulative normal CDF, both of them actually they take the shape of a sigmoid S. So that means an S which will approach to 1 and 0, but they will never touch the axis. All right. And what I say that logit model has a flatter tail. So either upward or downward, the tail is flatter in the case of logit compared to the probit. So that means if in your sample, if you see that too many observations are at the lower end or at the upper end, that means too many individuals are having either house or too many individuals are not having house. That means you are having too many observations at the tail. If you have too many observations at the tail, then please keep in mind, we must apply logit model. Sometimes we feel that we can apply logit or probit interchangeably depending on the choice. Actually, that is not the case. So logit and probit, how do you choose? Depending on your sample structure. If you have too many observations at the lower end or upper end, then we must apply logit. If your observations are like 40-60 or 50-50, that means 50% individuals are having house, another 50% individuals not having house, then the situation is basically a case wherein you can actually either apply logit or probit. So that means both logit and probit are same in the mid range. Okay, in the mid range. So I will just try to make you understand. I don't know whether I can log in through another device. Is it possible, Biju?
Sir.
If I start the meeting, start meeting or join the meeting, right? No, I think I have to go back and this is accept. This is the link. Yeah, so I think I have to start video and join, and yeah, I have to start video and unmute, and if I go to here, and then
It's working.
Yeah. So there is a whiteboard, right? So what I say is, this is the
Sir, I am sorry to interrupt. There's a small disturbance in the voice. If you could mute one of your mics, it will be all right.
So I
Is
think
this fine now?
the other login should be muted, sir. The video should be off.
So what should I do?
So the video which showing I
I should stop video here.
yeah. So whiteboard, we can see a white.
Okay. So what I'm saying that this is 0 and 1. So please tell me if you are able to listen to this.
So the voice is feeble right now. The older one, the voice was good.
Okay, so I don't know what should I do here. Anyway, I'll just draw it.
Now it is okay, sir.
Yeah. So what I'm saying, let's say this is the logic model, and this is the probit one. Okay. So one thing from here you should understand, this is minus infinity to plus infinity, and see this is in this axis I am measuring z. So when z ranges from minus infinity to plus infinity, this curve is actually ranging from 0 to 1, but it will never touch the axis. It will be asymptotic. It will never touch the axis. So what I'm saying, in this mid range, logit is actually equals to probit. Logit is actually equals to probit, and here when you are in the tail, you see that logit has a flatter tail. So that means it can capture the observations at the tail end better than the probit one. That is why I say that if your sample structure says that your observations are in the mid range, then it is better for you to, you can use any of these. But when your observations are in the tail, then actually you should use the logic model, not the probit one. Okay, is this fine? So this is how we decide the logic, probit, a different type of models, and the estimation technique is maximum likelihood method. But one thing you have to keep in mind that sorry. Yeah. So how to determine the goodness of fit of your model? Okay. How to determine the goodness of fit of your model? Generally, we know that R square is the measure of goodness of fit. Okay, but here in the context of binary response model or qualitative response model, we cannot use R square, because what is R square? R square is basically ESS by TSS. And that is basically coming from the idea that you have a scatter plot. So that means, is the eraser here? I should get the eraser. I'm sorry, I'm not able to find out the eraser here. In this case. Anyway, so what I was trying to make you understand about the R square. See, R square is basically this ESS by TSS, and this is basically coming from the idea that you have a scatter plot, and then the R square, and you are fitting a line which represent the average of your scatter plot. But if you in the context of binary response model, you see that this is one axis and this is one axis. So your observations are all lying either this axis, either 0, individual is having a curve, or here. So that means there is no scatter plot. So concept of regression line itself is different. Okay. So that means there is no average. If there is no scatter plot, if there is no average concept, there is no concept of ESS and TSS in this case. So that means the standard interpretation of R square is actually not valid when you get the qualitative response model. Then there are different alternative measures of R square that the econometrician they have derived. One is called pseudo R square and another one is called count ratio. Okay, pseudo R square and count ratio. So what is count ratio? See, basically when you devise a model and estimate the parameters alpha hat and beta hat, let's say you have estimated your, sorry, this is, I'll take pencil. So let's say you have given, this is your alpha hat and beta hat. Now using this alpha hat and beta hat, you will estimate your probability, pi hat. What is pi hat? The estimated probability that the ith individual will have a vehicle or not. So the idea is, first you estimate the model, get your pi hat, okay, and the pi hat will come out, let's say pi hat equals to, for example, I am saying pi hat equals to 0.7, sorry, 0.76. If the estimated probability is more than 0.50, we will assume that this is actually pi equals to 1. That means the ith individual has actually bought a vehicle. Now what I have to do? I have to go back and see in the data set. I have the original data about the ith individual. I will go back and see whether the ith individual has actually owned the vehicle or not. If I see yes, in the original data also, I see the ith individual actually has bought a vehicle, I will think this is a correct prediction. That means my model has correctly predicted about ith individual. Similarly, I will go to next individual, I will calculate probability. If it is less than 0.50 and the individual in the original data set shows the individual is having a vehicle, then I will think this is an incorrect prediction. Okay, so I will count how many correct predictions I get from my model. Then I will divide that with total number of prediction, which is equals to n. For n number of individuals, you can make only n number of predictions. So if you take a ratio of correct predictions divided by total predictions, that will give you R square. That is the idea. Okay, so this is basically the theory behind this LPM. In LPM, of course, since that is estimated by OLS, we can use standard R square. But in case of logit and probit, we cannot use the standard R square. Okay, so that's the idea. Now here in logit and probit, we assume that individuals are having only two choices. So that means choice is dichotomous. Either you own a vehicle or not a vehicle, not own a vehicle. Either you go for external financing or not. But sometimes the choice variable is not dichotomous, rather it is a polychotomous choice. Within external financing, I can go for debt financing, I can go for equity financing. So that means there are, let's say, three choices. Okay, issuing public bond, issuing issuing private bond, or let's say issuing securities. These are the three choices, or no, not at all going for external funding. That is also one choice. So you have four choices. Okay, 1, 2, 3, 4. So that means now your dependent variable, instead of binary, it becomes now polychotomous. That means in this case, what we need to do, we need to apply multinomial logic kind of model. And in multinomial logic model, one category will be treated as base category, and then we will see, compared to the base category, how the other two categories, probability of other two categories changes when any particular external, any particular independent variable is changing. So that is basically the idea of multinomial logic kind of model. So this is the idea of binary and multinomial logic model. And in our next class, we will take a data set, we will estimate, and I will show you some specific examples from the finance to at least make you understand how these models they actually work in empirical way. So with this, I would like to close my session today. But before that, I would like to take questions from the audience.
Participants can unmute your mic and ask questions right now.
Sir, I have a question.
Yeah.
So my question is in logit and probability model, like R square, we see the R square is more closer to 1, the model fit. So here, how can we interpret the model fit in logit and probability model? You have said that two ways. One is pseudo R square something. Can you elaborate more on that?
Here, yeah. So again, yeah. See, what you are saying is correct. R square is always treated as goodness of fit, but instead of applying standard R square, we have to use either pseudo R square or count ratio. Depending on the value of R square, you have to say whether you have made a good fitting or bad fitting. So that means if the ratio of correct predictions over total prediction is more, then obviously you will understand that you have set a good model. If that is a low, then you will see that you could not set a good model because you have made only few correct predictions, right?
So what
The
is the
ratio
standard?
of correct predictions should be more.
Sir, what is the standard value of that pseudo R squares? So that is what I wanted to ask.
There is no standard value as such. What we need to do in econometrics, see, more than the value, what we need to check is the significance of the R square itself.
Okay, that means chi-square value you are talking of.
Not chi-square value. See, the significance of R square is generally checked by F statistic. R square and F, they have some kind of relationship. Okay. Depending on that, I will tell you when you estimate actually the model, what is the overall significance of the model. Using that F statistic, we can actually check the significance of R square also, because R square, if I simply say,
but when we use in SPSS, in logic model, that follows a chi-square distribution and it shows the significance value. I don't know about Stata. So
no. Please hold on. Whatever software you take, econometric theory will not change. Please keep in mind.
That's okay.
Whether I use it as data or SPSS or EVUs, econometric theory is theory. That will never change. When I am saying the significance of R square must come from the F statistic, that means irrespective of your software, it will always be determined from there because it has a logic.
Okay.
What is the logic? Logic is that in one case, you do not include any explanatory variable in the model. That is called a restricted model. And in another case, you will include all your explanatory variable. Then I will see, compared to that unrestricted situation, what is the improvement in the explanatory power of the model when I include so many independent variables. Thereby, I will calculate two types of R square. R square restricted, R square unrestricted. Using that R square restricted and unrestricted, I will arrive at an F value, and that F will give you the significance of R square. But when you are estimating this type of binary response model, please keep in mind more than R square, what is important is whether you are getting correct sign and significance of the independent variables. Since R square does not have the standard interpretation here, that's why we don't break our head so much about R square in the context of qualitative response model.